Cool. Just before we begin, are you familiar with the platform? Have you had any mocks in the past?
Yes, so I've done a few mock interviews. One of them was a systems design interview. And my background's mostly in tiny startups and founding. So these are some of my first interviews ever of this type. I've given interviews, but they were generally more targeted at whatever
Right.
specific product we were making. Yeah.
And do you know what level you're targeting?
I'm targeting L5 based on what I've asked my friends and colleagues around. Yeah.
Excellent. Let's get started. So you said you've done once in design mock, so I won't talk too much about the platform, just that you have bottom left blue button to enable the whiteboard if you need to draw anything. Otherwise, we can discuss in the chat editor. And I leave the last 15 minutes at the end for feedback.
Awesome.
For the interview problem, do you know what CoderPad is?
I believe so. It's kind of like an online scratch pad that where you can type code and then it runs it in browser.
Precisely. So, well, it doesn't exactly run it in browser, but yes, you can execute it. It's an online collaborative code editor. By collaborative, we mean that text changes should be synced. And code editor, we mean that code can be executed, right?
Yep.
Now, the tool we are using right now is basically CoderPad. This company has different contracts with Meta, for example, with interviewing.io. They provide this shell editor. Now, we want to be able to use it for code interviews. So this is the goal we want to have in mind here. So you can assume in a typical session 2 to 3 participants, very rarely 3. Any kind of requirements like audio, video, whiteboard, notes, they're out of scope. The only thing we're focusing on are the collaborative aspect and the execution aspect, with a final requirement that content should be retained for 10 years. Final content.
Awesome. And you said with the code, it's just the collaboration plus execution, right?
That's retention, yes. Those are the only 3 requirements, yes.
All right. Awesome. And with the execution, is I assume like this interview software that we're using, all of this code is simple enough to run on, single small machine, let's say. Well, I guess that's a question for me to figure out. We're writing, less than 1,000-line programs here, so and so I'll get to that later. All right, non-functional. Okay, so let's go to functional here. You already wrote out a lot of them for me. I'm just gonna copy and paste some of these. And all right, so we want text changes synced. Code can be executed. Content retained. And that's it. All right, cool. And so, yeah, so we're going to have somebody, sending their typing to our system, and they're going to be receiving some up-to-date version of the document. Are we going to want, is it in scope that we may want them to be able to see the cursors and the names of other people?
No, just the editor.
Just the editor. Okay, awesome. All right, typing, they receive an up-to-date version. I think those are the big functional requirements. Let's talk non-functional. So obviously we need to be able to execute the code. Let's just say able to. This can be up here. The container enough resources to execute quickly. And then we're going to want the receiving of the up-to-date document to happen near real time, because that will really affect the user experience here. We are going to want to be the near real time may be more important than it's being consistent. And what we definitely don't want is it to slow down too much. And because there's going to be a trade-off there, but as long as it's eventually consistent within a reasonable amount of time, I think that's what's going to be important.
It's fine. Yep.
Yeah. Okay. And then let's see. Is there anything else here? I think. How is there a specified way to handle conflicts? Like if we end up typing in the same space,
No,
or is that out of scope? Or
there is no specified way to handle them. I would love to explore a few options.
Okay, awesome. Let's just say handle conflicts gracefully. So before I design the cloud architecture here, I do want to think about these conflicts because that could end up being an important point. So let's see, if we have two cursor positions, one thing we could just say is cursors can never overlap. But then if somebody's backspacing through text, that's not going to be great. I think what we can do, if people are typing and their cursors overlap and they end up, this eventually consistent thing ends up like missing a few characters or something at the most, I don't think that's going to be a huge user experience issue. Not a huge UI issue if minor conflicts show. So I think what we can say is, honestly, we can just have something just like the last type that's in, last message in wins overwrite.
Yep.
Yeah. I don't think that's going to change the UI that much, and it's definitely worth going fast. All right. So I think this handles largely what would make this fun. I think I'm ready to dive into diagramming this up. What do you think?
Cool. I'm happy with that.
Okay.
Let's go.
Awesome. All right. Headed to the whiteboard now. Probably going to be using desktop for this, but they don't have a desktop icon. All right. So, to make this go super fast at the expense of, well, first of all, let's keep track of everything here. So we're going to be sending keystrokes. Oh, that's a good question, actually. Do we want to send keystrokes or do we want to send a diff? Because we're going to have selections as well. Yeah, let's send this shit. Oh, sorry, what?
What are the trade-offs between keystrokes and diffs?
Yeah, so keystrokes themselves could be, depending on how we implement it, could be faster, because what we're talking about is like, say I delete a large section, I would need to keep track of what I have highlighted, and then that, so it wouldn't really be keystrokes. Yeah, a diff would be faster, because essentially the only way to make keystrokes work very well is to turn it into a diff. So yeah, I think a streaming diff would prevent us from having to keep track of like mouse selection and keystrokes all at once. So honestly, I think they would both work fast enough, like on the same order. I think diffs will end up being way easier for us to actually implement and debug and maintain.
Okay, happy with that. At some point, I'll also look at the format of these diffs.
Yeah. And then what we're getting back is the latest doc. This could also be a diff. What I worry about there, though, is we might have to have like keyframes. So let's say there's going to be a trade-off here between whole doc and something like a diff plus keyframes, because we don't, if we drop, some frame of data here, we're not going to want it to like that diff to run off the rails. And so we'd have to periodically send keyframes. All right. So then these are going to be, when we first connect, a load balancer is going to connect us to a session of some sort. And so that can be a microservice, but if we wanted to run really fast, we could actually have, we could have these be sticky instances. Also, if we're looking at speed, let's run this all over Websockets. And if we're looking at multiple instances here, we could do some kind of sticky session instance, almost like a game matchmaking service, where both, let's say this is user 1 and this is user 2, where they are both connecting to the same instance here. And on...
When I say sticky, do you mean like a WebSocket, or what do you mean?
Oh, by sticky, I mean that we're not going to be switching, by sticky, I mean both, we're not going to be switching, multiple instances won't be able to handle the workload in parallel. But, and so like, if our instance went down, for example, we would be losing some data in exchange for really fast speed and responsivity.
Right.
And
so this connection between the server and the client, how are the clients and the server connected? Is it a WebSocket, or is it more like HTTP polling?
Oh, it's WebSockets between the load balancer and then, WebSockets, and then the load balancer routes that to an individual instance.
Okay.
Yeah. So and I would say there's one way to design this where those instances just pipe those WebSockets into a message queue, but that will add a little bit of, and then we have microservices processing that message queue and sending it back, but that will add some latency. Whereas I think with like instances here with a let's just say with like a Redis database on each one, could run like lightning fast, and each, so I'm going to draw, we have this multi-instance here. This is single. This is one of, let's say, one of n. instances, and we're connecting both of these to everyone that's in the same on the same CoderPad would connect to the same instance, and their session would be sticky on that instance. So that's what I mean is they're not switching between these multi-instances.
Right. What I'm asking is how do we guarantee that everyone on the same CoderPad connects to the same instance?
Oh, yeah, great question. So I think what we would do is keep a registry of instances, and that does not need to be lightning fast. So what, there would be when somebody is loading it, let's just say the actual UI polling of all the instances that is out of scope, and we just have a URL reference. Would that be okay to start there with like a URL reference to a particular pad?
Yep, that's fine. That's fine.
Okay,
You can imagine. Let's take the example that we have right now. Just for the sake of demonstration.
Exactly.
Yep.
Yeah. So then in this RDB here, we would have some schema that is like the session ID, or let's call it the pad ID actually. The pad ID, and that is going to point to our session instance, which the session instance is one of these. And so then when I connect, what I will first go through is actually a matchmaker. Whiteboard, sometimes. Okay. Matchmaker. Which is just going to query this DB, and then it's going to these matchmakers could scale horizontally as well. I'm just going to use one of these. So it'll query that and then direct the WebSocket traffic to and from the correct multi-instance server. Yep. And so then let's see, I'm just running through some of our requirements again. Don't want to miss anything. All right, so we're going to sync the text changes. So we're going to have diffs that go in. We're going to have, how did I delete it? Still there. Some stuff popped back up. Okay, the code can be executed. All right, so let's get into that. Sound good?
Sounds good, but I also want to discuss a bit the diff format. How?
Okay.
Mm-hmm.
Yeah, sure. Let's look at the diffs format first. So the I'll be honest, I've never designed a diff system before, but I think what I would first look up is what like some open source tools that already exist use. So I assume that like something like git diff does something really efficient.
Let me reiterate the question. I'm not looking for like that kind of diff format. Just fundamentally, if something changes between two files, how can we encode that change? I'm
Oh,
thinking
I see.
within the Unix diff, yeah.
Yeah. So someone will be. Let me just pull this up. Someone is typing. Client. Actually, we do it. Yeah, I think it's fine to trust the client in this case because they're the ones typing. Client runs when someone is typing. Client runs diff on the document. In this case, the code that they're writing, and then sends stream of diffs. This is just going to be each one's going to be a diff from their current version over WebSockets. And this does not need keyframes. The reason being is it is going to be updated from the server-side authority. So it doesn't. These diffs will always be on, recently, not 100% up to date, but recently up to date code.
Understood. And how often will we send these diffs?
That's a good question. We're talking pretty small data here. We're talking less than, let's say to be really safe, less than like 10 kilobytes. Trying to think if there is anything else. Oh, by the way, we're not doing, you said voice is out of scope. We're just doing the pad. So I think we're sending like less than 10 kilobytes of data, even if they like copy and paste like the whole thing. So I think we could, honestly, I think we could try to send a diff every keystroke. Because we're sending it, the fastest we would be sending it is how fast someone could type. And so if we assume like, 200 words per minute, something like, max, let's say, way overestimating it, 100 per second, 100 characters per second. So that's 10 milliseconds per character, and those diffs would be tiny. Those diffs would be like probably less than 10 bytes. So I think we can do that. It's only like, while someone's typing, that's only like a kilobyte a second. And what's great about doing that is right when I hit a character, someone else is going to see it, which, again, I think that snappy feedback is what's really going to have a wow factor here for end users. We could certainly do it slower though, and then the trade-off there would be we would probably be using a little less bandwidth, which would be nice for like our costs and the end user's internet costs potentially, but at the cost of that responsivity.
I can do that.
Yeah. 100 milliseconds would probably be roughly, well, let's even say the refresh rate of the monitor, right? So we could cap this at something like cap at 30 milliseconds because nobody's going to be able to see anything faster than that anyway. So yeah, last character or right when a character is typed, but cap it at 30 milliseconds. So if someone's typing, may have multiple characters within that 30 milliseconds. It'll queue those and then send them all out at once. Send one diff out at once. Does that sound good?
Yeah, I'm happy with it. How does the multi-instance or a given instance process these updates? So let's say I get maybe 10 updates per second or something, right? 100 updates per
Mm-hmm.
second. How do we deal
Mm-hmm.
with that server side? What do we do?
Yeah. So what we're gonna do here, um, these Redis DBs, by the way, are actually on these little session instances.
Okay.
So they're happening super fast. And so what we're doing is we have a and we honestly the Redis may actually be the archive that we're having of this. Is it an archive of the history? Like, does it include the whole interview
It's
or
just
the whole tab or
it's
just
just
the
like a
end of the tab?
snapshot of it's just like a snapshot of the final content.
The final. Okay. Then actually, I don't even think we really need. Um, I mean, if this is just going to be an in-memory database, we really have one document, so we can just store it in memory. Um, so each of these instances, what they'll do is they'll have um, diffs that are coming at them, and these could be diff of user one, and the stream, is going to be mixes of diff of user one, diff user two, so on and so on. And the whiteboard is freaking out. There we go. And then on the inside of this server, we will be we'll have a queue of these diffs where we take one by one, take diffs in order from queue, merge into latest document, which will be in memory, and then let's say every 30 milliseconds, we already established that as a pretty good time, um, uh, uh, send or broadcast latest doc, latest broadcast diff from last 30 milliseconds to all um, clients. Does that make sense?
Partially. You are
Mm-hmm.
taking this in order from the queue and merging them. I assume by in order you mean in the order they arrived?
In the order they arrive, but what we would use is, it won't be a dumb merge. We'll need to use some kind of smart merge, and the diffs and merge algorithms aren't something I'm super familiar with, but again, I'd probably look at something like how does Git merge.
Merging is not my main question here. My question is if you are taking them in the order they arrive and you are going for such a low latency like 10 to 100 milliseconds, then it's
Mm-hmm.
very possible, it's very likely some of them will arrive out of order. So
Yes.
diff times 22 will arrive before times 21.
Yeah.
How do we deal with that?
I think if we're and so if they were all arriving in order, that would make our life a lot easier because the merge could not be very smart. But as long as we use a merge that is comfortable getting diffs out of order, like again, I'm pretty sure with Git merge, one branch can get ahead of another branch, and then you can use some smart merging algorithms there. That would, I think that would handle it. If I had to write my own of what that might look like, um, I would probably, the diffs will arrive out of order. I mean, you could timestamp the diffs. Diffs and then you could ignore diffs, that were sent earlier than latest. And so then, we won't be going backwards in time ever with those diffs. The trade-off there, though, is we do run some risk of like losing a little bit if two people are typing at once. But as long as they're typing in different areas, we only have to. That's a good point, actually. We could timestamp the diffs, and then we could ignore diffs that happened earlier than latest if they conflict.
Normally, I would agree with that, but if you're using a diff format, then say I want to type the word, I don't know, word, right?
Mm-hmm.
And let's say we update every keystroke. Then the update will say something like insert letter W, insert letter O, insert letter R, insert letter D, right?
Mm-hmm. Mm-hmm.
One of those arrives out of order, and that gets ignored, then we'll end up with a missing letter. If we just
Yeah, but I think it would only get ignored if you were editing the same like cursor positions as the other user, because that's where there would be a conflict, right? If you were typing in different areas.
Let me clarify what I mean here.
Okay.
So there's no other user typing, it's just me typing, right?
Okay. Mm-hmm.
And we have 4 changes. Number 1, insert I don't know why I can't write it down. It's Never mind, I'll just talk it out. So first update will be something like insert letter W. Second update will be insert letter O. Now, if insert letter W arrives after insert letter O, then that update will get ignored because it has an older timestamp, right? So now we'll have insert O, insert R, insert D. So we'll end up with ORD. But what happens with the letter W I just typed?
Right. I see what you mean now. One idea we could use for this, so we could reconsider the format here and move away from diffs to something else. But I think one way we might be able to manage it if we are using diffs is to create like a change like list here, right? That contains some some cache of the latest changes. And so this is, let's say this is O, R, D, right? And then, and so at any given time, this is our latest state, right? And then if we do, then when we receive the W, it's going to have a later timestamp. I'm just going to use these equals 2, 3 equals 4. Those are coming in, but we missed the W. Now we receive the W, and so this comes in with a timestamp of 1 on it. And what we would do then is we could insert this here, and then insert and rerun diff chain. Does that make sense? That's one way we could do it. Yeah, I don't know. That calculation may add some lag, which is what I worry about. Yeah. But
cool. I don't want to talk too much with this, so let's move on to code execution.
Awesome. Okay, so the execution, what I'm imagining, this we could have just a microservice. And so what I'm imagining here is we have, let's just say, exec microservice, and we will, honestly, this could have its own little separate load balancer as well, because we might be running on any given machine, we might be running multiple, pods of code execution. So this multi-instance here will have the latest doc. And so if somebody sends, and I think, for speed, we already have WordSockets open. So let's say there's a special signal here that's like exec. So I'm going to say diffs and exec are getting sent here. And then when the instance with the doc in memory receives that exec call, it is going to, no, I don't want dotted line. It's going to send a request to this load balancer with the latest code doc here. And then that load balancer is, going to funnel that to one of these microservices. And just to keep these from building up, what we could actually do instead of this being some kind of direct request, I think it would make sense for this to be a message queue instead, where we're just sending, whoa, I'm not going to change that, where we're just sending these jobs, right? Latest code doc job to, and that these microservices are all, just pulling from. And then similarly, on the way back, we're going to have the executed code return, or or console printout. And so the multi-instance would then be waiting for a message that it receives after that job's complete. On these machines, right, what they would be doing is they receive a document. They would start, let's say, I worry about security running it. But I'm going to say we start a container because that job will include the language. And so I'm going to say we start up a container that is configured to execute code in desired language. And then with doc as input or parameter. And then container console output would be streamed to final container, final console output put in message queue, outgoing message queue. Let's see document from message queue. Let's see. Actually, one question: will the console need interactivity? Like, will it need me to be able to say whatever? Will I be able to say like console.input or something, and it wait for me to type?
Basically, just typing code in a given language and then pressing run and getting the output.
Awesome. Okay, that's great. Thank you. Simple. All right. Yeah, and so these could spin up, or whatever, balance between any number of these. So this scales horizontally really well. I worry a little bit about security. I was going to say I worry a little bit about security with containers. as opposed to like a VM. So I just want to look into that. So we don't really. I think as long as it's contained on an individual machine, though, the worst thing that's going to happen is someone can hack and see some random other path's code.
Cool. So what will happen if, for example, someone has a suboptimal solution and it goes in a while loop, an infinite while loop?
Oh yeah, we should have, a timeout. There's actually a few parameters of this container. So the container will need to have a, timeout, in which case we kill and return console text up to a certain length. Let's say up to 5 kilobytes of console text, just in case they're printing like an essay on the console.
What will happen if they try to use an unreasonable amount of memory, let's say in like C++?
Oh, that's exactly what I was going to type next. Actually, we would specify container memory. I forget what you call it, limits, and what's going to happen if it hits the memory and it can't go anymore is it's going to crash. In which case it's kind of the same as if it errors out. So will crash if it hits. We could do two things. We could just return the error console, log. But we may want to be even nicer and say if it hit resource limit, return more detail, return more whatever user-friendly error, like ran out of RAM or ran out of diff, something like that.
Cool. Happy with that.
Cool.
So just one last question. In the overall system, where do you think the bottleneck would be?
I think right now, let's see, we only have 1 to 3 users. On each pad. The message queues could, be horizontally scaled. We're just pulling out of them from the microservices. So I suppose the bottleneck would be, this relational DB here. And, I don't know, I'm trying to think if we actually need the immediate consistency there. We may not. So we may be, if this is the bottleneck right now, I believe, may be able to move to something that's eventually consistent. And then I haven't shown the archiving yet, but I think that will also not be, I don't think that will be a bottleneck, because I think that'll be, a NoSQL document share that doesn't need to be ACID. It can just be eventually, but it should be durable though.
So what will happen if, let's say, we're at peak time, right? Obviously, as you pointed out, both systems, the execution and the editing, are horizontally scalable. We can add more machines, right? But what will happen if we have a limited budget, right? We don't want to add more machines and we're at peak load. And for some reason, these users are very kind of testy and they want to execute lots of code. Maybe it's at the end of the day, maybe it's peak hiring season and everyone executes code, right? And we don't want to machine to the execution side. What implication does it have for editing?
I'm sorry. I think I missed some of it because it cut out. So what's the what is the we don't have enough money, so we don't want to scale which part of this?
So let's say we don't particularly care about executing code anymore, right?
Mm-hmm.
We have a limited budget there for those machines.
Got it. Okay, so we're not
Now,
executing code.
what implications would that have for editing if we are already at peak capacity for execution?
Okay, so if we're not executing code, what effect might that have on editing? Is that the
Precisely.
we could probably do some peer-to-peer connections.
Sorry,
And so
let me reiterate the question. In this
oh,
system,
sorry.
the currently designed system, we
Uh-huh.
are slowly increasing the load. We have more users and more users, right?
Uh-huh.
At some point, users start compiling a lot more, right? And we
Yeah.
can't handle all that compilation need out there, right?
Yeah, users start compiling. Oh, we could compile locally, potentially. Sorry, that doesn't sound like.
I'm getting to. What I'm
Yeah.
getting to is, given that we can't compile anymore,
Mm-hmm.
because we don't want to allocate any more resources server side, and we are already at peak, how can we
Oh,
make
like should we send them an error message or something? Is that kind of what?
this is the first question. Let's assume we send them an error message, or let's assume we have a workaround like a local compilation. We'll go over that in a
Mm-hmm.
minute.
Mm-hmm.
But if we don't have any more machines, how can we ensure that the editing service is still scalable? Because I assume everything is going through a single load balancer from what I see here.
Well, so everything's going through a single load balancer, but I think if our let me just draw a line. If our if we're running out of machines to execute code, this will fill up. This queue will fill up if no execution resources. And so, I mean, we could be really not nice and just drop queues, drop messages, and then the instance that interfaces with it could just be like, it wouldn't have a nice error message there, but this queue is what would build up here if we weren't able to execute those jobs quickly enough. So, we could have a timeout. Well, sorry, to your original question, I don't think the editing functionality itself would actually suffer at all in this design if the execution microservices got overloaded. That someone would click run and they would just never get back an answer to their execution, but the editing should still keep working fine.
Happy with that. Let's go over some feedback here. I will just paste it in the shared editor, but before that, how did you find the problem? Did you find it easy? Did you find it difficult?
I loved it actually because it covered. I'll be honest, like one of my faults is that I've only used message queues in systems like once, so I'm normally very like it's not intuitive to me to be like, hey, we should use the message queue here. But this problem really got me to think that way because of these like code jobs. So I liked that. So love microservices and definitely they're my go-to for things. But I also love places where, microservices that aren't fully, I forget what you call them, fully partitionable are still really useful. And this is one of those, right? Having one instance manage two streaming users controls, right, could make this really responsive. So yeah, it's an exciting question.
Awesome. Yeah, it's a pretty difficult question as well, right? Because it has several aspects to it. It has a collaborative aspect. Um, from what I hear, questions like design Google Docs are particularly
Mm-hmm.
popular, and it has questions like the code execution aspect. Both of them together makes it quite a tricky problem. I
Mm-hmm.
will just send the
Mm-hmm.
feedback on line 32 and we'll go over it line by line. Can you see it?
Yeah, wait one sec. I always forget where the toggle whiteboard button is. There we go. Okay.
Right. So it's line 32.
Mm-hmm.
Plus is basically mean like that went well, right? Minus means something was missing, there was a gap, and if there is an equal sign, which there isn't in this case, it's just like a piece of advice or just some thought. Cool.
Mm-hmm.
Um, Started out really well, reiterated functional requirements. You anticipated and you also discussed how we would handle conflict resolution from the very beginning. You selected last right wins as a reasonable strategy. I was sort of looking for a bit more trade-off discussion between like different options. I
Mm-hmm.
think the summary there was, hey, we'll pick this because we don't think it will be a big deal if there's a small kind of conflict there, and we just pick the last right wins, which is reasonable. But I was sort of looking for other options as well, right? For example, I don't know,
Yeah.
locking the document, or something to read on is operational transforms.
Mm-hmm.
Because this applies fine here, because there are two people on in the session, and one of them is the interviewer, who will likely not write at the same time as the interviewee, which is fine. But if you get a problem like design Google Docs, you can expect like a book that's like 1,000 pages collaborated on by maybe 100 people simultaneously. So in that case, you
Mm-hmm.
really want some stronger way to solve these conflicts.
Mm-hmm. That makes sense.
Yep. Basically, at L5 and above, one of the key traits in these interviews is you want to discuss lots of trade-offs, right? And you
Mm-hmm.
did some kind of discussion. So you discussed trade-offs, for example, line 38, when updating, if you want to update on keystrokes or if you want to update a whole diff. And you discuss a bit of updates on the storage as well. You discuss trade-offs on the storage as well. You discuss some more trade-offs later.
Mm-hmm.
But even more, right? Whenever you can think of different ways to do things, point them out.
Yep. That makes sense.
Now, what I think was a very big miss on the initial part of the interview are these three lines,
Mm-hmm.
35 and 37, particularly the scale. We don't know what scale we are operating at, right? So if
Right.
I say, hey, why did we design this complex system? It's just like 10 users in a
Yeah.
coding competition or something, right? Why do
Mm-hmm.
we need all this? Why can't we use just like a simple doc, right?
Yep.
It's on the other hand, maybe we have a system that's like 1 billion users, and then I would ask you, why don't you account for data centers on multiple continents,
Mm-hmm. Mm-hmm.
right?
Yep. Yep.
So super important. Probably if you only have like 10 seconds for requirement exploration, figure out the scale. That's the most important part.
Okay.
The initial part, the way it went over functional and non-functional requirements, it was very methodical, right? It will be appreciated in every interview, but that comes at a cost. You are spending maybe 5 minutes on that. You are not really
Mm-hmm.
getting information. I don't think you asked me any question for functional and non-functional requirements, maybe just the conflicts, right?
Mm-hmm. Mm-hmm.
And everything else was like a monologue, meaning you would have been able to just say them upfront quickly, and that's it.
Mm-hmm.
There are some candidates who do this kind of 5 minute sort of discussion on availability versus consistency, and it always ends up we want high availability, eventual consistency, right?
Mm-hmm.
There are exceptions. There are some problems where you are fine with some loss of availability for strong consistency, but those are exceptions.
Yeah.
So in general,
Yeah,
if
it's
you
like bank. That would be like a bank transaction or something, right?
precisely.
Yeah. Okay.
So if you're always, or if you know you want to end up with that, just say it upfront, right? In 10 seconds, you could have just stated, for example, hey, we have the function requirements above, let's move on, right?
Mm-hmm.
It's less
Mm-hmm.
methodical, but save you some time for more discussion later. But that's just some advice.
Okay.
But if you want to make the most out of the time for requirement exploration, figure out the scale.
Mm-hmm.
That's the most important thing to figure out,
Okay. That makes sense.
right? Because you might not even need a load balancer, right, for that. Or on the contrary,
Yeah.
you
Yeah.
might have so many connections that you need some servers just to handle connections.
Yeah. You need like a regional replication, some kind of. Yeah. Yeah.
Cool. And the same with latency, right? You are focusing a lot in the middle part of the interview on having a lightning fast service,
Mm-hmm.
right? But what exactly does low latency mean? Sure, we want to have low latency. That's kind of obvious. But
Mm-hmm.
a number on that. Is it like 3 to 4
Right.
milliseconds? Probably not, right? And it
Mm-hmm.
feels more like that's what you were designing for, like a very kind of low latency, almost
Mm-hmm.
like video editing sort of low latency. But
Right. Right.
in this case, you can't, if I'm typing stuff on line 36, you probably can't spot a latency of 200 milliseconds versus 10 milliseconds. And
Yeah.
200 milliseconds or even 300 is very kind of easy to account for. You can even go as high as 1 second, right?
Yeah.
As long as the whole world arrives within 1 second, it's not that big of a deal, right? It's not that bad of an experience.
Mm-hmm.
So
Mm-hmm.
with a 1 second, let's say 500 milliseconds latency in mind, you can be a lot more relaxed here, right?
Mm-hmm. Mm-hmm. That makes sense.
So essentially things you want to figure out at the beginning, some important questions to ask are things like scale, latency, user distribution potentially, right? If it's global, if it's local. In this case, I would have said if you ask that it's mostly US-based users, so that basically your design worked anyway. But if it's a global system, they need to account for what you mentioned, regional replication,
Yep.
right? And there are other things there, security, for example. Hey, can you assume everyone is well mannered, or should we have an adversarial model in mind where we might have some hackers, for example,
Mm-hmm.
security primary concern, any kind of budget constraints that we have as a small university versus a large company designing this. So these are usually important questions to ask, and we want to clarify them upfront. I will just say budget
Awesome.
as potentially important with the question mark.
Can't hurt.
Um, Sorry?
Can't hurt to ask. They might as well just say it doesn't matter.
Yeah, exactly. What else? Some other things that are relevant are potentially the user, not the distribution necessarily, but more like the query distribution or the activity distribution. Do we expect it around the clock, or will all these, requests come within a very narrow kind of time span? And that kind of
Mm-hmm.
user distribution, but it could be something that needs to happen 24/7.
Mm-hmm. Mm-hmm.
Cool.
That makes sense.
Moving on to the feedback, I'm on line 40. So typically, what we want to see in these interviews are some back of the envelope estimates. Are you familiar with the concept?
Sorry, can you say that again? Cut off.
Sure. What we want to see in these interviews are some back of the envelope estimates. Are you
Yes.
familiar
Yes,
with the
I'm
concept?
familiar with that. Mm-hmm.
Cool. Because you did some of that later on when you were trying to figure out, okay, how much bandwidth are we using, right? Okay, we have
Mm-hmm.
about, I don't know, uh, 1 kilobyte in document. We update every 10 milliseconds, so we should be like 1 kilobyte per second or 10 kilobytes per second or whatever. So
Mm-hmm.
that's the kind of estimate that we want to see here. Now, some people just, did some training, did some kind of mock interviews. They know they have to talk about back of the envelope estimates at the beginning, and they just do some pointless estimates. Uh, I would say that's counterproductive because you are kind of wasting time and not using that number for anything useful, right?
Yep.
Maybe, I don't know, they're estimating, what would be a good example? They're estimated how much total bandwidth we need for our servers. Sure, you come up
Yeah.
with a number, say it's 1 gigabyte per second. What do you do with that, right?
Yeah.
But
Yeah.
there are some things you could have come up here that would have been useful to inform your high-level design if you asked about scale. So
Mm-hmm.
things the number of active connections you need to maintain because servers have a limited number of ports, so you might need a lot more servers just because you need the ports. Another thing could be the timeout. So how soon you have to time out, because if you allow each execution to run for maybe 10 seconds,
Mm-hmm.
then you might have a lot of concurrent processes going on that each runs for 10
Right.
seconds. Another thing could be the total QPS, because if you update every keystrokes and there are maybe 1,000 keystrokes per session, right? The number I would have
Yep.
given you for would be 1 million interviews. So you're talking about 1 billion uh, QPS per day. Sorry, 1 billion queries per day,
Mm-hmm. Mm-hmm. Yep.
which is not negligible, right? Now the one is storage. We discussed retention for 10 years, right?
Mm-hmm.
We never covered that in the, I believe, in the design. it would have been a relatively straightforward one. I'm not going to weigh down too much. It's just like having a concept to make sure it purges the table after 10 years. But the question is, how much, if I, without doing any estimates, right, just guess, how much storage do we think we need for all the content for 10 years?
Right. Yep. That makes sense.
What's the guess? So without trying to estimate it, like intuitively, how high?
Oh, you're asking me. Sorry. Let's see. It drastically depends on how many people are using it, but let's just say a terabyte.
1 million interviews per day, but don't try to. You just tell me an intuitive number without like running.
Yeah. So 1 million. Let's say maximum. I think like a terabyte, even.
Yeah, it's probably.
And so we could be safe and do 100 terabytes or something.
Cool. Yeah, if you do the estimate, it's probably around 36 terabytes. So you're quite close. In another magnitude, then you'd be safe with 100 terabytes. But conceivably, right, you want to run an estimate here to be safe. Some people, they estimate a number and they're like, oh, it's trivial. But others don't, and they over-design the system. They're like, okay, we need cold storage for this, and we need all this kind of fancy layered storage. But you don't need that. You can have a typical DB and it can store just fine, 36 terabytes. Even a laptop can store that.
Yep.
Right.
Yep. That makes sense.
Cool. Just moving on, you discussed trade-offs, routing, keystrokes of this. You elected to use Websockets to connect to instances, routed by a load balancer, which was nice. I was looking for a bit more discussion here, a trade-off discussion against other approaches, such as polling. If you think about it, and if you ask about the scale, as I said, 1 million. So it might not be, a fancy engineering solution, but it's perfectly reasonable to just poll every single second for the whole content of the document. So what was is like 10 kilobytes, right? 10 kilobytes per second is not a kind of big deal. It's relatively reasonable. You can do probably 1 gigabyte per second in some extreme instances, but 10 kilobytes per second is nothing.
Yeah, that makes sense. And a lot of the WebSockets may fall back to polling anyway.
Exactly. So you simplify your system a lot, right? You're like, I'm just polling the server for the most recent instance they have.
Yeah.
And telling them my latest change, right?
Yep.
So it will simplify the system a lot. And that's maybe a piece of advice I have for you here. Don't always assume that we want the most kind of complex or challenging solution. Sometimes the simple answer would work the best.
That makes sense.
There is this operational transform. I point on 937. It's an algorithm for how to solve this kind of collaborative problems. It's relatively simple to explain. It's harder to implement. But what it does is, if it gets a series of changes, so let's say you have change 1, change 2, change 3, and they are applied on a document D. Yeah.
Yep.
What it does is that after it applies change 1, then it recomputes change 2 using the new image of D. So for example, you added line 40 to do some stuff, and I enter the new line. Then we know line 40 becomes line 41, so it will just do all your changes on line 41. Right? It's reasonably intuitive to explain, but it's hard to implement, and I don't expect people to be able to implement it. But a lot of people, they assume we want operational transforms because we know about that. They try to explain how it works. They try to implement that, and I'm like, fine, I'm giving you enough rope to basically try it, but why? Like, we can just log the whole document, or we can pick an approach like you described, last write wins, and we're just as fine.
Yep, that makes sense.
Cool. No API discussion. So typically, I want to see some API discussion here as well. We discussed it maybe informally, as in, hey, we send this data, we get back this data. Like, hey, we send a request to execute the code, and we get back the results of the compilation. I was looking for more of a formal API, right? So what do we send? Do we send the user ID? Do we send some kind of authentication token? Do we send an API version? And what the format that we get is like a JSON, is some sort of, binary data. Does the client decode it? Not a big deal for this problem, but other problems might be more API heavy.
Yeah, but even with this one, right? I mean, even if it's all over WebSockets, you'd still at least maybe want to be sending, something that's like your credential with, your auth
That's what we're
token.
looking for, not just for authentication, but also to discuss how the data is structured, right?
Yeah.
Because then we were discussing the diff format. You write, I said, diff there maybe, and then later we figure out, okay, maybe you want a timestamp as well. So it's very easy to kind of add that change.
Yep.
Cool.
That
You did a back of the envelope estimate for the bandwidth. You discussed trade-offs against slower updates. I had to point out that we can't guarantee that updates arrive in order, right? I'm expecting you to identify that. That especially over WebSockets, over UDP, they won't arrive in order. You propose to merge diffs in the order they arrive, but again, they don't necessarily arrive in order. And eventually you propose a timestamp, right? What I was trying to get you to do there is try to take you away from assuming this is a fancy diff merge algorithm. You are kind of imagining this is something like Git or like version control. Those kind of algorithms would typically work here, but they would be too slow.
Got it.
Because if you think about, say, I don't know, when you run a Git commit, for example, or a Git amend or Git add, it's not instant, right? And you can even see it humanly, that sometimes when you have like 10 files, even it takes maybe a second. Or when you do a Git pull, it does take much more after pulling the changes locally by the network to just merge them in.
Yep.
Right.
That
so
makes sense.
I was expecting like something really simple here. Doesn't need to be any kind of complex algorithm. Something as simple as, hey, we take the start position and the start line, and we have the end position and the end line, and then we have the content, right? And content timestamp, and that's it. And that contains all the information we need. We could have some other information like annotations, credentials, and so, but it contains all the information we need for any changes, for inserts, for deletions, for edits, for selecting something, for pasting something.
Yep.
Right. And then what the server does is literally go to a text file in those positions and insert the content or update the content. Cool. Yeah, at some point you propose using a timestamp to avoid out-of-order diffs, but I had to point out that if you just ignore the older diffs, it will result in something that the users don't expect, like missing a letter, for example. And you further propose to keep a buffer of changes, which would work, but as you correctly pointed out, it will result in some potentially lag there. Right? What you could do is apply the updates anyway, tell the user, but then still keep the buffer. And if you get an old update, then you can apply it and update again.
Yeah, definitely. It's like, you backtrack.
Exactly.
Not in the programming way, but yeah.
Exactly. Initially, for the execution part, you never consider timeout and memory limits. I pointed out a bit, and then you went a lot further there. You discussed timeout, discussed memory limits. You point out security concerns, discuss sandboxing VMs. For the question I asked you, hey, how does this affect basically the editing? You had a very reasonable question there that we'll just use the queue. When it fills up, then we stop the updates. In some designs, what happens is that candidates go to the execution service straight from a main messaging queue or from the main load balancer. And when that happens, is what the implication there is that when the execution service fills up, we stop allowing collaborative edits, and that's bad. Right?
I see. Yeah.
But in your design, you go to a separate message queue, then you can just like have a limit on that queue.
Yeah.
It's not ideal though, because let's say you put a limit on that, like 100, right? Sometimes 100 will work just fine, but sometimes people will have just incredibly inefficient code maybe, or like a mistaken code, and all the machines are busy for like the full timeout interval. Other times they have very efficient code, it runs in like, I don't know, 10 milliseconds, and then they stay idle because we limited the queue.
So, yeah, so you could space them out.
Limiting the queue is fine. You probably want to do that, but probably with some way higher limit, but then have another load balancer.
Yeah.
Cool.
Yep. 100%. Yeah,
overall,
that makes sense.
I noticed you're in the discussion well, so that's what I was looking for at L5 and above. More general candidates, what you'll see them struggle with is find the next topic of discussion. They talk about something and they'd be like, should I talk about anything else? Are you happy with that? Like, yeah, you identify the topics. Also, good written communication, clear drawing, easy to follow along. I always was up to speed with where you were, so I like that. If this would be a real interview, it would probably be on the fence between hire and no hire. I'd probably go with a no hire, mainly because of the scale reasons, right?
Okay.
If you're asked to design a system at scale as a senior engineer, I would expect you to ask, okay, what scale are we designing for? But there were other things. That alone wouldn't be a fail on itself, but there were other things, for example, the API missing, some trade-offs that were never discussed. Had to point out a few small things. In principle, though, I would say that the scale was the main thing. So if you asked about scale and latency, it would probably be a higher.
That makes sense. Yeah. So clarifying, designing for correct scale, latency. I'm just, if I had to choose three, it'd probably be, and then trade-offs, you think?
It would be more trade-off discussion, especially on the important decisions, like, for example, Websockets versus polling, and the API discussion, having like a formal API in place. Because we are mostly focusing on the server side right here. So in the real world, you would have probably a client-side team that would be doing this polling, would be doing maybe, I don't know, the UI, the syntax highlighting. So we need to agree on API first of all before even designing the system.
Yep, that makes sense. Yeah, and the API, I guess, would also help inform some things that I might miss on the system side.
Yeah. Maybe when you design the API, you figure out, hey, you know what, we actually don't need WebSockets, we're fine with polling, or you know what, we want a timestamp, where do we store the timestamp?
That makes sense. That makes sense. Well, for the API discussion, would that be a good first thing to do when I move to the whiteboard? Is be like, here's the client, here's the API?
It depends. I recommend doing it first, even before going to whiteboard. Can discuss it in this CoderPad, right, in the shared editor. But some people approach in different ways. Some people have a go the high-level design first and then propose a contract based on that. I recommend doing it first of all because that's how you would do it in the real world. Your interviewer might be a front-end engineer in the end, right? So you want to have an API that you both agree on, you and the interviewer, before you design the high-level design. Otherwise, maybe you miss something, right? Maybe we don't want to get the compilation result. We want to get something like I don't know, standard error as well.
Yep.
Having that upfront kind of helps with the requirements as well.
Yep. That makes sense. Cool. Awesome. All right. Well, I'll definitely kind of review all of the feedback, and then those three things I'll focus on.
Excellent. Awesome. So good luck with your prep and good luck with your real interview then.
Awesome. Thank you so much.
Pleasure. Take care. Bye-bye.
All right. Bye-bye.